TEK 12b is in the polynomial category, but it is actually a TEK that we're going to address in all 3 or 4 units in this class, in the linear unit, in exponential unit, and in the quadratic unit. It's applicable to all of the units that we cover. And it says that the student is expected to evaluate functions expressed in function notation given one or more elements in their domains. Okay, this TEK is it seems very basic, but its application beyond this particular type of TEK is astounding in math. You have to understand this notation. So in other words, when we're using a function machine where we have inputs and outputs, where we have x values and y values, we can call it x's and y's and know that our y's are our outputs, or we can use function notation. Now this right here, all right, is called function notation. Now what happens is it tells us the name of the function. In this case, this function is named f, and the input type that we're going to be using. So in this case, this function will have inputs of x's. We may have a function called h of t. That's how you pronounce that, f of x or h of t. The name of this function is h, and we're going to use the variable t. Now it's important that we have this because if we're using multiple equations at the same time, we're not going to be like the top equation and the bottom equation. We're going to want to name them something different. So we would name them f and h. We would know the difference between them because they have names, and we'd know what should go into them because we have their input in the parentheses. Again, this is called, you pronounce this f of x. Function notation, f of x. So what I really mean here is we can have an equation written in the classic way, y equals 2x plus 5. Or we can write the same equation in function notation, call it f of x equals 2x plus 5. Same equation, I'm just using a different way to talk about it. Instead of using just y, I'm going to use f of x. It's more information, it's a little bit higher quality math speak. But what I want to be able to do is to be able to put different things here in the input and change the equation. So it's set right now, it says f of x equals 2x plus 5. But if I said, let's take the function f and let's write a t in there, well, the equation would now change to 2t plus 5. A second ago, this had an x right here and right there. So since now I changed the inside or the input to a t, I need to change all my variables in my equation to a t. To reiterate this, what if I had f, that's not what I wanted. Maybe. If I had f of heart, a symbol. We use letters in math to do symbols, but what if I had a heart? Well, this would say 2 of heart plus 5. Again, all I've done is replaced the input value in the f of x to f of heart, and therefore replacing every x with a heart in the rest of the equation. We need to be able to do this for numbers in the function's domain, which means we're going to be putting not just other symbols or letters in there, we're going to be putting different numbers. If I did f of 2, now instead of putting t's or hearts everywhere there's an x, I'm going to put a 2. Now it's good math to put that 2 in a parenthesis so that we know we're multiplying them together. If we just put a 2 next to a 2, it would look like 22, and that's confusing. Since we have solely numbers here, no more letters, no more symbols, we can do this mathematical problem. This is something I know how to do in my head or in my calculator, and I can do so. So I would calculate 2 times 2, which is 4, plus 5, which is 9. So we would say that f of 2 is equal to 9, or that we have the coordinates 2, 9, because that's my inputs and my outputs. So right away, function notation tells us a ton of information about different functions. So we'll jump right to the practice problem here. If we're given this equation, and yes, it's a more complicated example because this does go through every unit we use. Okay, this is actually a quadratic example. It says p of x is equal to 5 times x squared plus 1 plus 16. What is the value of p of 11? Okay, well, we know that this is the number I'm going to want to plug in to the original equation because it told me take the function p, here's the function p, and instead of an x, I'm going to write an 11. Okay, so let's do that. Here's function p of 11. I'm going to write down the equation exactly again, but when I get to that 11, I'm going to write, or when I get to the x, I'm going to write down an 11 instead of the x. I only have numbers left, so now I use my brain or my calculator and I start calculating. 11 squared is 121. 121 plus 1 is 122. 122 times 5, that's 10, that's 11, that's 160, or 110, plus 16 would be 626. The nice thing is once you get to this part where you have it all the way plugged in, you can use a calculator. I like math, so I like to do it all the way out in my head to challenge myself, but we can plug that into a calculator and see what the output or evaluated form of that function would be. Now, this is one of the most important skills you need to have before heading up to higher level math classes. Even our class, again, this sort of skill right here that we're going to use goes into things we're going to talk about called transformations in our class, as well as applications in transformations in Algebra 2, pre-calculus, calculus, and all the way up. Even your geometry classes are going to use the idea of function notation to determine changes for a function. So maybe, perhaps, we're using function notation to do something like this. This is an important transformation idea. We know that that means, oh, just plug in 3x for every x we see in the equation. Really understanding that f of x is the same thing as y is very huge to keep a grasp on what's going on in this class. As always, we empower, we impact, we love, we are Skeeter Nation.